Hi, how are you? Can you hear me? I guess I haven't been teaching for in Zoom for a long while since the COVID. I hope you're safe. I guess it's kind of interesting that we have to meet in Zoom. I would rather meet in person, but I guess if we don't meet in Zoom, then it would take a very long time to for everyone to meet again. So let's see. There's still some people want to get in. Let me see how. All right. Yes. So everyone's able to get in. So I hope you can hear me. If not, then please leave a chat here. But so since I don't see you, so let's start with the something you reply, right? Let's start with this one first. While we are waiting for everyone, I guess let's see if your internet connection is okay. Maybe we can do a we can wait 2 to 3 minutes, right? We can do this question. So you can try to log in and um, try to see if you can write down something to see your system works out. Uh, we'll start 3 minutes later while we are waiting. Oh, let me change it. See, sorry for that. Let me do it again. Sorry, A B C D, right? Sorry for that. Let me do it again. It should be one item. Oh yeah, multiple choice. I'm sorry about that. Sorry, I made a mistake. Someone remind me that happened. So please do that in again. I'm sorry about that. I hope that means that it's good. You guys are actually doing that. Yeah, that's good. Yeah, sorry for that. Thanks. Okay, we have some of you are doing 2 lessons and then tutorial, so I hope that would be fine. I never have a class in typhoon number 10. I think I do have typhoon number 8, but I never tried number 10, but this is my first attempt. Um, oh, yes, I do the same. I didn't sleep very well, and verbal leakage. I do have the same issue, but indeed, my house actually, I mean, my apartment actually have some leakage actually. So my wife and I this morning have to clean up a little bit, but still doesn't affect me that much. But yes, I don't think we sleep very well because of worry. And I guess some of you are watching YouTube or online last night because we're happy. Yeah, good. Red morning. Yes, yeah, lucky. So good, stay safe. Yes. It's pretty scary. Luckily there's not much thunderstorm, so at least it's not going to be that bad. Oh, oh, I'm so sorry about that. Have some coffee. I do finish. This is my the third, second cup of coffee. So you do need that. So maybe today a little bit slower, but try to make sure it's more interesting. Okay, good. Then know most of you are safe. Um, so let's get into the business. I guess it's a random variable. I try to see if I can collect my iPad. That would make things easier, but not entirely clear if I can do that. Let me see if I can do them using my uh, iPad on. Let's see if I can do that. If I can do that, right on the right corner. Let's see, I can see them. Let's see. That's great. Oh, where's it gone? Can I see my screen? Is it okay? Can you see my? I think you can see my my slides. Good. So let's get started. So random variable. So let's see what we are going to work on it now. Let's put it down right. I need where I need to. So so I just hope let's review what we have done last time. So why we care about random variable, right? Because the first thing to think about it is we learn probability, right? And the last chapter, probability is like kind of calculations like complicated, right? And potentially the sample space can be very complicated, right? Because you need to a detailed description of what it might be. Of course, you can simplify it, right? But potentially the describe what might happen in the future can be rather complex, right? Just remind you the thing, right? If you toss a coin 10 times, right? Then it could be a bit a lot, right? So it can be like if you toss it 10 times, it will be 2 to the power 10, right? If you toss, say suppose you toss a coin 10 times, how many outcome you can have is 2 to the power 10, right? So it is kind of like let me switch on the aircon. So it's kind of like it takes a very long while, um, a lot of things to calculate. But if you remember, if you just care about number of head and tail, if you toast 10 times, then it just you can have 0 times, 1 time, 2 times, up to 10 times. So only 11 outcome instead of uh this is like 1024, right? So 1000 outcomes. So just toast a coin can be complicated, right? You can imagine how complicated if you try to model, say, stock market, right? Stock market, the price can go up and down, but there are different price, even up and down. If you have 1,000 stocks, what does that mean? It means 2 to the power 1,000. Okay. So this is not possible to do it to collect data on this kind of stuff, right? So it would be easier to think about the scenario that you just say, I just care about the stock market indexes, right? Say Hang Seng Index instead of 1,000 stock over there, right? So that would be the way to go. Okay. So let us very briefly go over the idea, right? So random variable is a kind of function that assign number to outcome, right? That means that if I have a outcome that I give number to it, right? So why? Because it's how we measure, say, the stock market, right? Or that is how we simplify the thing. So that is one way to do. Okay, so that is when measure thing, when we do things, then you turn out that is easier, right? So that's why later you see the bell curve is something that we will be doing. Okay? Seems like it's better not to share through the iPad because it doesn't seem to be good. So let me go back to the normal one because it seems like the Wi-Fi is the iPad is not very good. Let me just share this screen and do it exactly this one. Maybe this is better. Let me open this one. And then can I do the full screen for this one? Yeah, I don't know how to do full screen that, but anyway, I hope this is fine. So so that is the idea. So just remind you what support. Support random variable is like what a kind of number you can assign to it, right? And it is important to notice the difference between discrete and continuous, right? Because as I said last class, discrete and continuous is the fact that what kind of math tools you can use, right? For discrete, you can use the high school math, but for continuous, you have to use the integration or differentiation, the calculus idea. But in the class, we just rely on high school math here, so that's why we don't really worry about that part. Okay, so that would be the case. Okay, so we focus on discrete in the upcoming two classes, 2 to 3 classes, and continuous will be the remaining 1 or 2 classes. Okay, so for discrete is where natural you use a finite support or countable finite, so you can count them 1, 2, 3, 4, 5. For those who learn math, then you know there's a huge difference between finite and infinite. Okay, countable finite is just how many people would come, right? There's no upper bound, right? So how many customer would come, right? You start from 0, but can be any number, right? You can't make a number that's the end, right? It can be more than that, right? It can always. But of course, in the world that many of things that is potential is finite, right? Say suppose, right, number of population, right? How many customer can come to your shop physically will be potentially a finite number because this is bounded by how many people in the world, right? 6 billion people, right? Kind of more than that, right? But sometimes potentially, if you should say, you model the situations over time, so over many years, then you can be any number you can go, right? So just usually what we usually for our case is discrete means integer, right? So integer is our key here, okay? So just go back to this example we have done last time. We have very simple tossing a coin. It's head or tail. And we can assign head to any number, tail to any number, right? But for it to make sense, right? Let's do the case where we focus on total number of head, right? Then head means 1 and tail means 0, right? Of course, it need not be 1 or 0, right? If you think crazy, it can be head is 99, tail is -10. So you may ask why this, and if this makes sense, right? Maybe in a gamble, head give you $99, tail give you -10, you lose it. So it's possible for this number to make sense, but so let's use the easier one, which 0 and 1, which is normally making more sense, but potentially this any number would work. Okay. And let's see the idea, right? This is head, you give you the 1 and tail gives 0, right? So just what it is, remind you that random variables a function, right? You tell me the outcome, I give you a number. Okay, so exactly this is what we want. Okay, so this is the idea. Head gives you 1, tail gives you 0. As I said, you can give you other numbers. Say you don't like this, you type 99. Okay, and this -10 is also done. It's also okay. But as I said, this may not make sense unless you're a very special gamble you're doing. So we are in our example, we stick with this one. But as I said, any number would work as long as there are meaningful reason behind it. Okay. So the next one is you toast coin twice. Okay. And remember, you toast a coin twice, so you do things in 2 steps, right? Each step has 2 possible ways to do it. So you learn from last class, principal counting, how many different outcome is 2 times 2, right? Because 2 in the first step, 2 in the second, you multiply them. And if you draw a tree diagram, also you can see with first round, you have head or tail, and second round, you also have a tail here, right? So each round, you have 2 outcome, right? So that's why it's 2 times 2, okay? And here, what we try to, this outcome, right, is head, right? And this outcome is head-tail. And this outcome is tail-head. And this outcome is tail-tail. So what we want is to assign number to it, right? Now we assign this is now assigned to 2, okay? And this assigned to 1. This assigned to 1. This assigned to 0. Why? Because it's number of head, right? So you have 2 head, 1 head, and 1 head, 0. Okay. So formally, you can write this, right? This is the way you write function. Okay. And very last point is support. Support is what kind of number you can put in there. You can have only 0, 1, or 2, right? So this is how we write this, right? This is a random variable idea. And the support, right? So basically, if you draw the diagram, right, the mapping, then you head, you will be mapped to 2, tail and head, tail, and tail map to 1, and tail map to 0, right? So that is how we do it. And particular, you will notice that the important is like this. You can see 2 outcome mapped to the same number. That is super important because this actually simplify our sample space, right? Remember, you have 4 outcome here, now become 3. Okay. So it makes things easier to analyze, right? And also number sometimes, as I said, we should pick a useful number. So this number will be meaningful, right? So suppose you are betting on a number of head, right? So then you win $2, right? If for each head you win $1. So that would make this number meaningful, right? Okay. So I hope that would make sense to you. Or you can think an airplane, right? Airplane have 2 engines, right? Engine 1, engine left, engine right, right? Maybe head means the engine are okay, so 2 engine are functioning. Head, tail, and tail head means the left engine is working, the right engine is not. So this is maybe you need a emergency landing, right? Or if left doesn't work, right work, then you can land, right? But if tail, then engine off, both engine are failed, then probably you have to pray to the god or luck would need it to survive. So that would be the way that you model, right? Because you don't really care about whether left or right engine fails, and only if engine fail, then probably you have to um, have some probability that you have to go down. So that would be the idea. Okay, so I hope that is clear why we talk about random variable to simplify. And sometimes when we measure, we don't need the all possible outcome, but rather the outcome were interesting. Usually it's a number, and number is a random variable idea here. Okay. So I guess I covered that already. Just said you can count number of tail as well, but here it just only care about the head. Okay. And I also mentioned that there's a continuous random variable. In that case, it's something like we use real number, right? And we often when we talk about financial numbers or the stock price or will measurement, right? Temperature, rainfall, wind speed, right? Then will be a temperature, right? So you can see, right? If I think a good example with typhoon, right? Typhoon is the wind speed will be the real number, right? And our observatory have for a typhoon we have several number, right? 1, 3, 8, 9, 10, right? And these number are discrete, right? And of course, they have some meaning, right? But this is how the observatory give number, right? So that's you can do the random variable. This is discrete, right? If you're a typhoon, right? And but the wind speed or the rainfall is continuous, right? Because uh if you have temperature 37 and 38, right? Any number in between is also doable, right? But the typhoon number is 1, 3, 8, 9, and 10, right? Now it's 10, right? And last time is 9, but 9.8 or 9.5 or 9.3, right? It's not typhoon number. So these are not doable, right? Then the discrete is the case is we just list out all the number there, right? And you can't add anything new. But if I give you any number for a random variable for continuous version, then I give you anything, then I can just usually if I do anything, do average, do the median, do whatever, in the median number, it will still make sense. Okay, so that's continuous. It's like the law there. Okay, so I hope that makes sense why we need that. And if you do, as I said, you do financial number, then you will be there like temperature is above the absolute zero, negative 273 degrees in the Kelvin scale, right? And this is stock market, right? The stock price start from zero up to any number, right? So that is what we have here, okay? I hope that's okay. And then just to remind you why I need to distinguish between the two because of the math. For our class, doesn't really matter because we don't actually talk about how to do this precisely. Um, there's some way to do it in calculator, so we don't need to know the critical math behind. But for those of you who actually want to go further on data analytics, want to do big data, want to do probability, want to do data science, then you need to do risk management, then you need to know or do investment. But for the moment, for this class, we just use the usual high school math tool to do it. I hope that's okay. Is there any question before we proceed? Because from the map, I don't see you, so maybe if okay, then you can leave the message on the Zoom, say you're okay, then I see whether you're still here because it's hard to see your face and I do not know how well you are doing. Is that okay? If you're okay, then maybe you can say okay, leave a message there so that I can see if you're still around, you're safe and sound. Good. Thank you. So I guess it's okay. So let's continue this random variable because this is very important because random variable tell us what the numbers they are, right? Then we have not yet talked about it's the most important thing is probability, right? Because random variable is just for each outcome in the sample space we give a number, right? But we didn't say, okay, what's the probability? Because that's the most important thing, right? Because we want to know how likely that an event happened. And that means that when we convert the outcome to number, we want to know how likely the outcome or the number would comes in, right? Because X can be a number, right? Go back to the example. The discrete case is typhoon, right? 1, 3, there's no 5, 1, 3, no, there's no 7, is 8, 9, and 10, right? And of course, that is probably you can add 0, which is no typhoon. Maybe you can add that number. That means that we want to know how likely that each one would comes out, right? So that would be what the observatory doing, right? Estimate how likely that in next hour, how likely that which number will comes out, right? So that would be the supercomputer in the observatory, they're doing this kind of activity in their mind. So just basically you put probability to each number, okay? And this is exactly what we want to do is you give me a number, I give you the probability. And this is the most easiest case to describe random variable is what we call the probability mass function, okay? You give me a number x, x a number. In a typhoon case, you give me a number 1, 3, 8, 9, 10, or in the case I have 0 as well, but when there's no typhoon, right? Then this is what we have, right? So you give me a number, I give you probability, okay? This is called PMF. And sometimes some book use probability function or probability distribution function. So that would be the same name, but different thing, right? The same name, but same thing, but different names. So I guess let's go to the example to see what it is. But although it looks very trendy name, but it's just nothing. But just give a number, you give me a probability. So old friend, tossing a coin, okay, a fair coin. You know, be fair, but just simple for the fair coin. The sample space is head or tail, and x be the random variable number of head. The number of head means that tail is 0, head is 1, right? Because that is we can't have number of head, right? So exactly we have here head you give 1, tail you give 0, okay? And we know that the probability of head is 1/2 because it's fair, right? Probability of tail is 1/2, okay? And do note that this is axiomatic definition, right? Because we actually don't toss a coin enough, right? But we know it's fair. By the axiom of probability, we know that combined with our knowledge, we know that head or head are equally likely. So as they add to 1, each of them must be 1/2, okay? Since tail is 0 and head is 1, so that means that if I have 1, the probability, you give me 1, the probability is 1/2, right? Because head means 1, right? You give me a number 0, which means tail, so which is probably 1/2, right? So that is the idea, right? And this table you can draw, right? The table you can draw is here, right? So that's right is 0 is 1/2. 1 is also 1/2, right? So this is the case where the coin is fair, right? But suppose you are told that the coin is unfair, right? Suppose it's not 1/2 and 1/2, right? Then suppose this is like 1/3, 2/3, right? It's more likely that tail would happen, right? Then in that case, instead of 1/2, 1/2, you would have this become 1/3 and this become 2/3, right? So this is how you can change the number, and this all will change as well, right? So I hope this is clear to you what we are doing, okay? Is how you give me a number, okay? I give you probability. So this is the probability mass function, okay? And this is the way that actually we stopped last time, right? So let's continue next way. So this is another way to describe the discrete random variable, right? So just tell me that instead of exactly the P, what likely number, but you're asking what is the probability that you give the number, how likely that is this number is less than or equal to that number, okay? Suppose I again have typhoon example, we have 1, 3, 8, 9, 10, right? And also 0 as well. 0 would be no typhoon, right? So the probability function x, right, will give exactly how likely that the probability or the random variable equal to that particular number, right? P of 3 is likely giving me the probability that the typhoon is number 3, right? But F is actually asking slightly different, right? If F of 0 is asking how likely that is the random variable is 0 or less, okay? number this or less. And if the probability f of 1 is asking how likely that the probability is less than or equal to 1, so it means this number. Okay. If we have f of 3, then it's asking is probability that the random variable is less than or equal to 3. So it's like these 3 add up together, right? It's 0, 1, or 3. Okay. So similarly, if you have f of a, okay. Sorry, I should use another color. Maybe other color blue here. Like f of a, okay, will be add up of this 4 number, okay, because asking less than or equal to, okay, equal to is included, okay, all this number there, okay. So it's just adding up what is it and before it, okay. So this little bit not so concrete, little abstract. So let me give example. Again, our old friend, get over it. It's tossing a coin, okay? And we just covered this part, right? The previous example, right? If I toss a fair coin, how do you have a P, right? P will be, you give me the value of X, I give you the probability, right? It's a fair coin, and head is 1, tail is 0. So this is saying that X is 0 means this is tail is 1/2, this is head, right? So this is what we have, okay? So now we look at the new one we learned, just F, big F. Big F is asking, okay, what is the probability that the random variable is equal to this number and less than that, okay? So F of 0, okay, F of 0 is asking like, how likely that probability that the random variable is equal to 0 or less. But you can only have 0, right? So less is just 0. So that's why I just copy down there, 1/2, okay? The next is F of 1. Okay? F of 1, this guy. Why is 1? Because asking how likely that the random variable is equal to 1 or less. 1 or less have 2 cases, which is 0 and 1, right? So just like this, F of 1 is asking probably X is less than 1. So you have 2 cases, 0 and 1, right? And these two are mutually exclusive, right? So that's why this is from the axiom 3, right? From probability, right? Because these two outcomes are mutually exclusive, right? And there's nothing you can have is probability is 0.5 is 0, right? Because it's either 0 or 1. So only 2 cases relevant, 0 or 1. So we just add up the P0 and P1, which is 1. So that is how we do that. Okay. So now let's see a diagram. You can forget about this. It's very technical, how you get the axiom, but let's see this graph here. I think if you understand this graph, that will be, you understand everything there, okay? So let me use green color, orange color, right? So this is P, okay? And remember, the random variable is capturing number of head. So 1 is head, 0 is tail. So this table here, okay? X is 0, table here. And we have P equal to 1/2, 1/2, right? Because it's fair coin, so it's 1/2, 1/2. Tail is 1/2, head is 1/2, right? So that's why when you try to draw it, I use different color. Of course, you don't have to, you can use the same color here, right? And tail means the red color. Blue is the 1, right? So all of them are 1/2, right? Because the coin is fair, right? If you are unfair, then it will be, say, different from 1/2, maybe something smaller, and this one something bigger, right? But in this case, we have equal likely, then is this, okay? And how can you work from P to F, right? So remember, the big F is asking how likely is this number or less. Okay, go back to P, right? F of 0 is look at P0, okay? And look at before, there's nothing before. So we just have this, okay? The same as the P, right? So it's same as what we do in the kindergarten, right? We're doing Legoing, okay? And when we have 1, okay, we just copy the 1 here, okay? And then we just stack. Look what has before it and stack it out, okay? So from F to P, what we do, we just look at each number, go back to the P, look at what is it there, and stack whatever before and put it all the thing up, okay? Stack everything less than that and up, okay? This is what F means, okay? Get everything before and put it up, okay? Just building a tower using some Lego pieces, right? Just building a tower here, okay? Okay, so let's do another example, which toes the coin twice, okay? So we have head, 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 tail, and tail, head, right? So just to remind you, right? And the random variable is number of head, right? So this is 2, and this are 1, and this is 0, all right? So that is what we have in this line here, right? Head, head is 2 because 2 head, right? Because we count number of head. Head, tail, and tail head are 1, and tail, tail are 0. And do note that these 4 outcomes is equally likely, right? But the probability of the random variable is not equally likely because head, tail, and tail head are 1, right? So each outcome, although have probability 1/4, right? But probability of having 0, of course, is still 1/4, but 1 is no longer 1/4 because 1 represents 2 outcomes, right? It's head, tail, or tail, head. So it's 1/4 plus 1/4 gives you 1/2, right? The last one is still 1/4 because 1 outcome. So here we have something different, right? So the P is not a flat bar, will be later you see in the next slide, will be different heights, right? Because 1 is more likely than 2, right? Having 1 head is more likely than have 2 head, okay? And this below we explained already, right? Why we have this number. I'm not going to repeat it, but you can read it, okay? If you want, but already this logic is there. And look at F. How do you do F? F is looking at the number of the P and go back, right? So how you get 1/4? You just go up to check what is above there and go left, okay? And there's nothing left. You just that's why it's 1/4. How about big F of 1? Y is 3/4, okay? 3/4. Because go up, it's 1/2, right? And add everything there, right? Because remember the idea F is stacking the P. So you get itself 1/2 and add back what is there is 1/4 plus 1/2 is 3/4. Lastly, we look at what is why the F of 2 is 1. Because look at the P is 1/4 and to add whatever before it. So the phi number here, add up must be 1 because the number must be below 2, right? Because the maximum is 2, right? So F of 2 must be 1, okay? Because F of 2 is adding 0, 1, or 2, right? Because asking the random variable is less than or equal to 2, and the maximum of 2, so it's just must be 1, right? So to give you the idea, let's look at it graphically, right? So as we saw here, right? Each outcome is equally likely, but tail is 0, head, tail, and tail, head is 1, okay? And head is 2, right? So that's why when 0 is 1/4, when it's equal to 2, it's 1/4 again, but 1 is 1/2, right? Because this refer to tail, head, okay? And also head, tail, okay? So that is the reason why you have a slightly different shape, right? And from left to right, from P to F is stacking, okay? So what I'm going to do is look at the first one. Red is same as this guy because you 0, go back to this graph and see whether P here, okay? Is there anything before it? Nothing, just itself, right? There's nothing new there, okay? But when you look at the 1, okay? You just follow what we have here, right? You just follow what we have here, okay? And see what is before it, right? Look, before you have a red there, okay? What you do is stack there, right? So you stack there, that is 1/2 plus 1/4 is 3/4, okay? And lastly, you have 2 here. You just get whatever 2 is in the P, okay? And then you try to stack things, stack this to here, okay? And stack another one, okay? You just stack them up, okay? So add up together. So from P to F is you're building a tower, right? Look at the left-hand side, whatever that is grabbed, you stack it up, okay? But that also means that uh, if you do the unstacking, you take a difference, okay? You take a difference between these two heights, will give you this guy, right? So you can easily go from F to P. So if you're able to, from P to F, F to P, they can be interchangeable, right? So, and you may ask why we have to do F, right? Because P is something more intuitive, make more sense. Why we do F? The reason is for discrete case, for sure, P is more meaningful. But for continuous case, later you will see we will do F. F is something uh more interesting. Okay. And this is something we can say easily in continuous is F. P is not well defined in continuous because P is asking probably equal to that number. But later you will see in continuous case, P is always 0, right? Because suppose I ask you to pick a number between 0 to 1, any number, okay? And you can, if I use computer generate a number there from 0 to 1, uh, it equal to a particular number will be 0 because there are infinite number of them, right? Exactly the number you pick is exactly a number that is random nature from the experiment will be 0. Okay, so that's the idea why we don't have the P for continuous. Later you will see, but for discrete P is very important, right? But for continuous, F is the most important thing. Okay, so before we have break, maybe we can talk this after the break. We'll talk about the fair die. Okay. In the meantime, I think we should have as usual, let's have a section where you can ask question, right? So let me do the break here. Okay. So let's have a break of 15 minutes. Okay. In the meantime, if you have a question, please feel free to leave in the chat because I can go around to ask question. So let's have a break of 15 minutes. Then we resume at 11:30. So if your question, you either unmute your mic, or if you don't want to just message in the group, or you can just leave in the group reply, I will answer. So let's have a break of 15 minutes. I'll see you soon. I get some water. Actually some coffee. Okay. I hope you have a good break. I guess break at home is better than, or coffee shop rather than break at the lecture theater. I hope that be there. But let's fill that in. I mean, you have done so, not done so. Please fill that in. But let's check out what do we have. Yeah, it's raining heavily now, but no, not really. It's nothing in my area on Hong Kong Island, but here is nothing. There's no rain, surprisingly. Yeah, no, but yes, I love McDonald because I also love McDonald because it's no need to cook in the in this time because the only thing that's open nearby is McDonald in the big typhoon. Not very okay. Oh, oh yeah, don't worry. So if you let me know because that is a kind of attendance or participation. So I hope you fill that in if you have time. Um, so there's a question about memorize. Oh, probably you are not here in the first class or first few class. Our our class has um it's open book. So you don't need to remember the formula. You just write down in somewhere, you bring the notes, then it's fine, right? So you don't really need to remember. You just need to know where to find the formula. And I'm not, I mean, maybe you need to know some Excel function, but other than that, some calculation may be needed, but some basic calculation, I don't think I need. It's not high school, right? So I'm not keen in asking how to operationalize some operation. So not, this is not something I would be asking. I mean, particularly, but in the past I did ask how to give you the number and how you calculate. Yes, you can bring calculator. Some of you asked me in the chat. Yes, you can bring calculator. Yes, no problem. As long as it's not uh they have no Wi-Fi function, I don't care, right? The only thing I worry about is a Bluetooth that may facilitate cheating. Otherwise, I don't really care because you can bring whatever you can bring to the exam theater. You can bring calculator, but I guess it's not super helpful. I mean, because we don't have too much calculation, but it would be helpful to bring the calculator because there may be some calculation, some division or some multiplication, but otherwise, shouldn't be a big concern. Oh my God. Okay. Sorry about that. I guess it's learning through the Zoom is not that easy compared to in-person lecture, but I guess because maybe we may have more typhoon, so I guess that's why the school allow us to do online, but hopefully we can resume in person on Friday. That would be much better because teaching is also terrible in Zoom, right? Because I can't really see you, so uh, this have no face-to-face interaction. Uh, Pretty not good, I would say, because you're talking to the screen, right? You're listening to the screen is not just like you are. Yeah, if you know it's Wednesday, that's good. And okay, I think this now everybody agrees rainy and windy and cloudy is my location, but I guess in your place it's very rainy. Uh, so that discrete and contour, yes, exactly. So we have fx and px is something we learn. Uh, well, I guess we haven't learned this yet. Sum of expectation. We'll do that very soon. It's waiting. We'll do that. Uh, Maybe you are already ahead of us. We haven't learned this already, but there's probably mass function there. Yeah. Cumulative distribution function CDF, yes. We learn high. Did we learn high? No, I don't think we learn high. But that's okay. But I guess you are learning what we're doing. I think so far it's okay. Not too fast, but I don't know too much because it's online, right? It's very easy to get distracted. I can understand that. I mean, probably some of you are watching YouTube or TikTok or playing games, which I can't really see, but hopefully we can resume in person so we have better learning experience there. And there, not today. Well, I only drink coffee and when I'm too tired. When it's too much, I think at 3 cup will be okay. At most 3 cup, but I think 1 or 2 when I was very tired like this. But otherwise, if say if there's nothing like yesterday, then I don't drink. Maybe some tea. Tea may be better, but I don't really know tea and coffee which one would be. But I mean, of course, you have to drink water as well. Yeah, I guess and I can tell you at one point when I was a undergrad, I the first year, I same as now, you guys are second year because we have 3 years college at that time. The first year is like you from the high school, then you come from the college, then things become so overwhelmed because so many things to study, and that's why I drink coffee every day. And in the second semester, basically coffee has no use to me. Then I stopped drinking coffee because after a year of caffeine, that's not very useful. So I suggest you only drink coffee when you really need to. Um, yeah, I hope you have good sleep. Well, okay. Why turtle can live so long? Because of Guilin Gao. Okay, that's interesting. I like that one. Why speed Hong Kong should appear directionless? Okay, because speed have no direction. Oh yeah, that's true. That's a good one. I like this um physics jokes. I like that one. Because this is a vector. If you learn physics, then velocity is the speed with direction. So that's a good joke if you learn uh high school physics. Nothing. I need coffee. Yeah, because coffee is good, but I think people in the West they drink Red Bull, but I don't know how Red Bull is. Maybe too strong. But you love my background? Thanks. Because my real background is not good enough to show. Just a white wall and some clock over there. And some of my kids ask stuff, so better not to show you because it's very distracting. Hopefully okay. So I guess if you don't have any question, if you question, please type in the chat. If not, then we go ahead to go back to your class. If any question? No? That's great. If there's nothing, then we continue our journey. Okay. But let's get back to our business of random variable, and then we learn before the break of how to describe them. Is big P and big F, right? Just to remind you what's the random variable. Random variable is assigning number to outcome. Suppose you have a say roll a die, you have 6 outcome, right? And obviously the most natural random variable is simply the number that you see on the face, right? What is if one facing up, then it's 1, right? So that is very natural way to do it. And I would say this is most reasonable one, right? And X just the integer, right? So here we have if the die is fair, then each outcome appear equally likely, which is 1/6 because 6 outcome. So the P of 1 is just 1/6, P of 2 is 1/6 because 1 is actually 1, right? So each outcome is equally likely. So that is 1/6. And now let's go to the big F. Okay. Big F will be just look at what happened to the P and just add before, right? F of 1, you just look at P1 and get any number before, right? Just 1/6 because nothing before it, right? What is F of 2? Why is 2/6? Because you go above, it's 1/6, you add what is before. So 1/6 plus 1/6 is 2/6. Again, you go to the third one. Why F of 3 is 3/6? Because you go up and add everything before it, okay? So it's 3/6 because 3 of them, right? Because this is asking what is probability that the random variable is less than 3, right? So less than 3 have only 3 outcome, 1, 2, and 3. So add them up, right? So basically just go up and all the left, okay? Because that is what the stacking, right? Look at what you have and what is before it, okay? So let's look at the picture because this gives you clear idea graphically, right? So the P will be 1/6, right? I didn't write that, but this is 1/6, right? In particular, right? So there's 1/6 for each of them. right? Because 1/6 is 0.166, right? So that's below 0.2, right? So that is what we have here. Okay. And just to remind you, a technical point, when actually you go to the stat department, they would not give you the bar chart, but they would do this dot and point chart. This is 1/6, right? 1 is 1/6, 2 is 1/6. But they will also tell you that you have to say what happened is between 1 and 2, right? Because P of 1.5, say, will be 0, right? Because there's no chance that you roll a die, end up with 1.5, right? So they would do is put a line there and put a empty dot there to say this go up to here, right? So this is what you would do formally in stat department. But we are not stat, so but I just put it there in case for those who actually go to stat to study further, they would be surprised to see this. Okay. The bar chart is not the formal way to do it, but it's enough for our purpose, right? Because we know it's not in the bar, then it's 0. But if you wanted to make explicit, this is the way to do. Okay. But this is technical, so you can give this for your assignment, right? But if you really want to be serious, this is the way to go. Okay, again, the f of x is stacking up, right? 0, 1.6, 1/6, 2/6, 3/6, 4/6, 5/6, and 6/6, right? And this one way to do it, but if you do it in stat, it will be like this. It's a step function go up like stairs, right? Because each stair go by 1/6, okay? And again, this is very technical. Why this is a, say, for example, this number, right? 1.5, right? Because f of 1.5, right, is asking what's probability equal to less than or equal to 1.5. So just go back. It just same as when you have 1, right? It's equal to f of 1, right? Because there's nothing between 1 and 1.5, right? So that's why it's a flat line here. Up until 2, it go up again. So it's just like staircase. But if you don't get it, it's okay, because when you need it, you learn it, because it's a statistics. It's a formal way to write it. Okay. I hope that's okay. So now we learn something new, which is something I guess is the most important thing to describe. Because as we learn, P and F are the way to describe random variable X, right? P is telling you that what value, you give me the value of the random variable, I give you the probability. F is, okay, if you give me the number, I give you the probability equal to less than that value, right? And P and F are the same, and because you can change one way to the other, right? To the same way, a complete description of the random variable. It's like the data set is completely describing what might happen, okay? If we can summarize the future by the random variable. But the problem again is same as what we learned in the very first class, right? It's very complicated. It can be the P can be very different, very weird shape, right? And F can be very different weird shape, right? So the point is, can we have a single number to describe the random variable? Okay, and we learned that from the very first class, the number that summarize the data is the mean, right? So the idea that we want to know what might be a random variable, because a number, we can calculate the mean, right, of the random variable. What mean about the data? Suppose hypothetically, we do a random experiment, the idea, right? Just we keep observing the X many, many times, hypothetically, right? And how each number would realize based on P or F, right? You say P, right? According to P, right? Suppose you roll a die of fair die, right? Then if you roll many, many times, 1/6 of time will be 1, 1/6 of time will be 2, and so on and so forth until the number 6, right? Each number equally likely, right? And if suppose you have 6 billion times, and 1 million time will be 1, 1 million time will be 2, and 1 million time for each, right? So you can calculate mean of this 6 million outcome, right? And each outcome will match to the random variable. And you calculate that, the mean of these values will be what we call expectation, okay? And simply means is x times px, okay? And it's add them all up, okay? So why is the case, okay? Suppose, let me, before we do that, but that is just asking, as I said here, just a mean of random variable you do many times, and P is the relative frequency. So this is the weighted mean here, okay? But let me give you the idea why this is a weighted mean, okay? And that is related to the random experiment idea again, right? So suppose we toss a coin once, okay? Only once. And then suppose I care number of head is the random variable, and you have only two outcomes, head or tail, right? I care number of head, so this is 1 and this is 0, right? So if you have the P is 0, P of 1 is 1/2. So this is what we have just learned now, right? But if you want to say F of 1 is 1, right? And F of 0 is 1/2, but you can easily swap between the two. They're the same thing, okay? But the key here is like, suppose I repeat this 1 million times, right? And then what we observe, the relative frequency should be same as the P, right? If we have 1 million times, okay? And 500,000 should be head, 500,000 should be tail, okay? Because it's fair, okay? So it means that the data, what you have is, you have 1 million data will be 0, 1, 1, C, C, 1, 1, 0. These are all the data if you actually toss a coin. But you have 500,000 head, 500,000 tail, right? So if you look at this data set, suppose this data, you calculate the mean, right? Means that you add up all this number divided by 1 million, right? Then you have a 500,000 in the numerator and 1 million in the denominator, right? So let me go to the next slide, right? Because you have all the data you have is 500,000 0, 500,000 1, because half of them will be 0, half of them will be 1, right? Because we run 1 million times. And how many times you run this experiment? 1 million times. Okay. So it will be 0 times 500,000, right? And over a million. And 1 times 500,000 over a million. And this is exactly the frequency, relative frequency, which is probability, right? And this is how we say in this, what we define, what we call the random variable. Okay. And let's go back. This is the mean, right? And this mean of this data of our hypothetical experiment is what we call expectation, is E to the X. Okay. So mean of the random experiment is exactly expectation. Okay. So that means that if you keep running this experiment, on average, the number you got, okay, is expectation. Okay. So that is what we mean by expectation. So let's look at an example here. Suppose I toss a coin, okay, number, and the random variable is number of head, right? So we know that it's a fair coin. So 0 or 1 is equally likely, 1 and 1/2, right? So what is expected value, right? That means that if you run this 1 million times, right, you expect half of them is 0, half of them is 1. So the mean should be 1, right? Mean of this data set, right? But you can also calculate by x times px, right? And that's the formula, right? And add them all up. So just what you do is you pick each number x here, you multiply by the p, okay? That is what you do here. And you would take the other number 1 here, you multiply probability p, okay? Then you add them up, okay? Then is what you get is the expectation, right? So that means that you expect the number you get is 0.5. Of course, there's no 0.5 in data, right? Because it's either 0 or 1, okay? But 0.5 is a number, right? It's somewhere you expect this number to be if you run this data a lot. That's what the expectation means, right? It's not you have a number 0.5, right? From the random variable there, but it's saying that on average, this is 0.5. Okay. So of course, this expectation will make sense if the random variable is psi, it would make sense. Otherwise, the expected value doesn't mean anything, right? Because you say, suppose if you pick head is 99, right? And tail is -10, then the expectation will be replaced by 99 here, right? -10 here, right? So does it make sense? I don't know if it makes sense. If this is gambling, it's what you earn when you have had, then this number will be on average, this is how much you earn, right? But only if this makes sense, right? I hope that's clear. Okay. And let's look at the other example. We roll a die, okay? And these are the number that you might get, right? It's a fair die, so each number is 1/6. So how to calculate expectation is basically you pick up number 1, okay? Pick each number there, you multiply by its probability, which is this one. And you go to second number there, which is 2. You multiply how likely it is, 1/6. Okay, that's what you do in the second number. And so on, and you do the third number, 3. You multiply by 1/6, right? And do the same, right? And you get 3.5. Okay, you do all the number. Remind yourself what we're doing. Suppose we have 6 million rolling the die, right? 6 million, you have 1 million 1, 1 million 2, 1 million 3, 1 million 4, 1 million 5, 1 million 6, right? And this is the data you have. You calculate average of this data, right? So that means that you will have 3.5 as average of data. So that is the expectation. Okay, I hope that is clear. What do we have? Okay, so it's 3.5 average value when you roll the die many times. But of course, rolling a die, you don't have 3.5, right? But if you have many rolls, 3.5 is the number we expect to be. Okay, so hopefully it makes sense to you that 3.5 is there, right? Just remember what's the mean. Mean is the number in the middle by distance. So you have 1, 2, 3, 4, 5, 6, right? So what you see will be you have 1 million of 1 here, 1 million 2 here, 1 million 3 here, 1 million 4, 1 million 5, 1 million 6, right? So the mean will be just the number here 3.5 because the distance to the left you have 3 million below and you have 3 million above, right? And you add up distance exactly 3.5 is they cancel out the distance. Okay, I hope this is clear what it is, right? What is the expected value. Okay, and later you will see this expected value is what you learned in the investment class is if you X is the stock price, expected value is the expected price, right? What you think about the price in the future, right? On average, right? So if X is the return, the expected value is expected return. Okay, so that will be what you learn in what will you learn in finance class if you haven't studied. So it's a very important concept there. Okay, so here there's some interesting thing that going to see and will be very useful for our calculation or also for finance, okay, or accounting or whatever. So it is very important. So if we have some constant A and B, say A can be 1, 2, or any number, 1,000, but remember constant means the random variable, you give the number to it, right? So A and B are number. Any number you can give, okay? There's no randomness there, so it's constant. And next be the random variable. Remember what's random variable? Random variable is not variable that's random, but rather it is a number that you assign to outcome, okay? And what number you get depend on your random experiment, right? You just end up with dependent nature what you draw there, okay? But we can have the following, okay? Expect the value if A times X is equal to A times expected X. Okay, so some of you ask what I'm doing here, okay? Why we care about this, okay? Why you care about multiply a random variable by A? Why you care about this? The question is like this, okay? Suppose X is the stock price of a stock, right? And you not just have whole one stock, you have 1,000 stock, right? So A is 1,000. Okay. And what might be the value of my portfolio, right? Tomorrow, right? That will be A over X, right? Because X will be the random variable of one stock. And I have 1,000 shares, right? I multiply by 1,000. And that will be the expected value of my portfolio, right? It will be 1,000 of the value of the stock, okay? So that will be just times 1,000. Why you think that is, why this is important? The important part is I don't need to model how my portfolio looks like, right? I just need to model the shares, how the price of a share, and then multiply by how many shares I have, and that is the expected value. I'm done, okay? And that will make our life easier because we don't need to model how the portfolio, but I just model one single stock, okay? And this is very important, okay? And that will simplify a lot of calculation. And it doesn't hold for everything, but at least for expectation, this is something that we can, okay? Later you will see this doesn't hold for variance. The variance, if you multiply by, you have 1,000 shares, the variance is more than that, okay? It's not just multiply. So that is only hold true. The linear idea just hold true for this. And linear property means you multiply, is same as you multiply it, is same as you take out the number as well. And you add a constant, it just X and B there, it just as you can separate them, okay? What is this? Okay, you would ask. If X is a stock, B is a cash, okay? So your portfolio has stock and cash. In that case, and you can separate them out. You can don't need to worry about the cash you have in the bank. You can just focus on stock. So you can divide and conquer, focus on what is changing and what is not changing, right? The B is not changing. Okay. So that is very important. Because you don't need to worry about the whole portfolio, right? And if you combine the first and second, they give you the idea what you call linear property. You multiply by a constant and plus a constant, you can write in this way, okay? So that would make our life much easier, okay? That is something you would do when you do financial investment class. Okay, let's give you an example there. Okay, that is why I do a stock idea, okay? Suppose your stock, okay, have three possible prices, 1, 2, and 3, okay? And this, the probability of the price equal to 1 through 3 is most likely you will end up in 2, okay? It's 1/2 of time. And 1/4 of time, you go down by to $1 and $3 is 1/4, okay? So the question is, okay, I know look like this, right? So what is my expectation, right? So on average, what's my value, right? So what's the number you give me, okay? Is the stock price because it can have few value, right? So we want to see what is the middle, right? Middle price, right? Well, that's the mean, right? Middle price. That's expected value. What you do is you take each value and multiply by its probability, right? So 1 times 1/4, right? And you take 2 times 1/2, right? And you would take 3 times 1/4, okay? And then you add them up, right? You give you 2. You can use calculator, but or you can say 2 is in the middle of 1 and 3, right? So you can see actually 2 is there, okay? So if you invest this stock, one stock only, okay, the price on average will be $2. So the next question is, if you have 1,000 share of the stock and $300 of cash, what is the value of your portfolio? So it will be 100x plus $300, right? The cash is not going to change. I mean, we are not considering the bank go bankrupt, but the money may be in your under your bed, under your mattress, so it's not going to change the value. There's no fire, so keep the same $300. Okay. And then because of this 100 can take it out. Okay. You can focus on one share, right? But we know that this is actually 2. Okay. So that's why it's 100 times 2 plus 300. So on average, your portfolio value is 500. So that is how you would do this calculation there. Okay. So that means that we only need to focus on a single stock, right? So that's why you can see why the stock market only focus on the trading of a single shares, right? You don't need to worry about the portfolio thing. The reason is just multiply, right? How many is proportional to how many shares you have. Okay, I hope this is clear. This is the proof. I don't really worry about that much. So the next thing is you learn from the stack. Our first class is beside mean. We want to know how good is our mean is the variance, right? Mean is one number you have, but we also care about how good the mean is, right? And if you remember, one of the most useful thing that we learned from the first chapter is variance, right? Variance about how different is from the mean, right? You should still recall variance, right? The formula is over n and add all up, okay? And x minus x bar squared, right? And sometimes you say, okay, you may care about the sample is -1, but we don't need to think about -1 because this sample we are getting is infinite many, right? Because hypothetically we run as large a sample we want, so there's no data there because it's sample is the whole population. So we not doing a sample. We are thinking about we run this many times as many as we want. So we care about the n is the population version. Okay, and this is the variance, right? And we get into our probability that will be this formula. Okay, and that will be taking the mean, the value minus the mean, okay, weighted by its probability, which is how many times it appears, right? Because this is the part, the red part is actually this guy, okay? It's adding how many times it appeared, okay? And this variance, remember, is how good is our mean, okay? So if you learn finance, okay, this variance is exactly the measure of risk. Larger the variance, more risk you have, right? So that's you learn the basic finance, right? And basic finance will tell you that if meet the basic thing you learn, the investment is mean and variance, right? Expected return, expectation, and variance. And you know there's no free lunch. So basically, if you want higher return, and you have higher variance, right? Because everyone want lower risk, right? Because people hate risk in general. Okay. So these two are the most important thing, right? Because to describe a random variable. Of course, big P and the big F is the most important thing. It's the most complete way to describe. But if this is very complicated many times, so we focus on the main thing, expected value and the variance. Okay? So that's why when you go to look at the stock market, right, we focus on these two measures, right? And of course, the more important thing should be looking at the P and the F, right? To do your investment. But the thing is, these things are very difficult to figure out. These two are very easy to guess. Okay, you will learn from the next class, right? We will not learn how to estimate this from the data, but rather we learn how to do it. Okay, to estimate P and F, we require you to go to much higher level classes, maybe 4,000 classes instead. But in our elementary statistic class, we focus on estimating mean and variance, okay? And probably you learn from the first class, you ask whether we do kurtosis and skewness. Yes, that's possible, but it's also beyond our class. So our class, from now on, we focus on mean and variance, okay? So just to remind you, this variance is same as we run this we run the experiment many times, have the data. We also calculate variance from that data. This exactly gives you this formula, okay? So let's see what we have here. Okay, run the die again. Okay, it's fair die. We learned already the mean is 3.5. Okay, so let's show you how to calculate variance of the die. What we're going to do is to pick number there, number 1 there. Okay, and you subtract it from the mean and take a square of it. Okay, and multiply by the probability there. Okay, it's 1/6. Why you do that? In fact, what you're doing is if you have 6 million outcome, right? And 1 million will be 1, right? And 1 million of 1 will minus 3.5 the mean, and you times 1 million times, and then you divide by 6 million times. So that's 1/6, right? Because 1/6 of them will be this value. Okay. And then you do the same. Look at number 2 here. Let me use another color. Number 2 here. Number 2 here you have, and then you subtract from the mean with 3.5, and you raise to the power square because that's the variance, right? Variance formula is you take any value, you minus expectation, okay? And you square it, okay? You times the P of X, okay? And you add them up, right? So that's the formula for variance. So that's why you take the value 2 here, you minus the expected value, and you raise the power 2, which is here, and you times the probability P is here, okay? You do the same for the rest. Let me do one more for you. Suppose you have 3, right? Number 3 here. And subtract is expected value is 3.5, okay? And you multiply by 1/6, see, okay? And you do the rest, you give the value is 2.916, okay? This is the same as what you learn in the data here, right? If you have a data, it's exactly this one, then this is what you get, right? So I hope that is clear what we have here, okay? And here we want to show you this formula, and this formula tell you that this is not linear, okay? Variance is not linear. So you can see variance of A of X is A squared of the variance, okay? So it's not just A, but A squared because variance is a square measure, okay? So that will be A squared, okay? So it's just like if A is 1,000, so maybe easier. A is 10, then it's 100 there, okay? So if variance is the risk in your mind, okay, then if you take 10 stock, then the variance will larger, right? 100 times of a single stock, right? Because the 10 stock can go up and down, right? Much more, okay? But of course, for those of you who think you don't want the variance, right? If you want the standard deviation, right? SD, right? If it's square root SD of AX, it will be A SD of X, okay? So that means that SD is still linear in that sense, right? If you multiply 10 times, if you measure the risk by standard deviation, it's still 10 times of that, okay? If you like the SD is a measure of the risk is just multiply linearly, proportional to the stock you invest. But if you talk about variance is your measure in your head, then your risk is actually much more than linear, right? If you 10 times, it become 100 times because it can fluctuate much more, okay? So it really depends on what you think is a fair measurement to your mind. Is it more risky? That is a variance. If not, it's proportional to SD. Okay. So the next is if you have variance of X plus B, okay? And imagine this is the risk, right? Plus the cash in your hand. Actually, the risk doesn't increase, right? Because there's no change in your cash, right? There's nothing changes. The risk of your portfolio, if your stock plus cash, is same as just the risk of your portfolio with only stock, okay? And the cash has no contribution. the cash has not contributed to risk. So that's why variance is a measure of the risk here. Okay, so let's see the example of the stock. Okay, and then we talk about the risk. If you talk about risk measurement by variance, we can want to look at the portfolio that have 100 of X and 300 of cash here. Okay, so again, we have the same idea here, 1, 2, 3, and the value of stock can be 1 with 1/4, 2 is 1/2, 3 is 1/4. Okay, so we know that the expected value is 2, right? So we calculate that EX is 2, right? So we want to calculate the variance of X. Why? Because we want to care about the variance or the risk of the stock, right? So what we do is we take number 1 here, okay? Number 1 here minus the expectation, take square times 1/4. Why? Because variance of X is X minus E of X, okay? And times the P of X, okay? In square, okay? So that's why 1 minus 2 square times equal to E, okay? And next we have 2 here, 2 would minus the value of X and raise to the power 2 and times how likely it appeared is 1/4, 1/2, okay? And lastly is number 3, okay? It's 3 minus 2, 2 is expected value here, and squared it, and times how likely it is 1/4. So end up, you can calculate it using calculator or Excel. You calculate this as 1/2, okay? So the variance is 1/2, okay? So this is a risk measure, okay? And the question is, okay, now the portfolio, we have 100X and $300 cash. So what's the variance of 100X plus 300 cash? Remind you that the cash has no change in the thing, that you can safely forget about it, okay? And because of 100X, you just square, take it out, right? Because that is what the meaning. Variance of A of X is A square variance of X. So you have a square. So very important, you have a square. Okay, so the variance is when you have multiplied by constant, you have to take it out, you have to make a square. So that become 100 square, and 1/4 is from here. So 1/2 is from here. So 5,000. So the measure of the risk is 5,000 for this portfolio of 100 shares of X plus 3,300 cash. Okay, and if you add more cash, actually the same measure of risk, right? Because cash has no bites. If you increase the 1 million of cash, the portfolio, the risk still the same. Okay, so that's the proof here. I'm not going to detail or talk about those. Okay, and just want to say something about this as a conclusion. Although we talk about in a class, we put a number to an outcome of a random variable, okay? And indeed, you need not put only one number. You can do 2 number or 3 number or 4 number, right? So that's what we call bivariate random variable, okay? So suppose you total coin twice, or you invest 2 different stocks, that means that your price of 2 stocks there, right? So stock A and stock B, then you need 2 variable, but that is way beyond what we can cover in the class. But potentially you can have 2 random variable, okay? We just use it without defining it how to use it formal. So suppose you have 2 outcomes, just 2 random variable, 2 random variable, right? Each outcome 2 random variable. And to describe it, you have more complicated. You have to call the joint distribution and marginal and triple joint. So this is way beyond what we want to cover. If you want to look at it, you can look at the book. Okay. But what I want is to talk about this property, which we'll talk about this again next class, is if you have two random variable add together, expected value of x plus y, it just simply add them together. So this read as expected value of the sum is sum of the expectation. Okay. And also if you expect a times x plus b times y is a plus x expected value and b times expected y. So what's the use of that? X and y are two different stocks, right? You have 1,000 share of A, right, in your portfolio and 500 share on B, then you just do this calculation. So that part, we'll talk about this on Friday. So hopefully that will be more clear. So I hope that's end. I hope you're safe and sound, and then we'll see you on Friday. Okay. So thank you very much. You're attending the lecture in online in Typhoon 10. So I hope you'll be fine. Okay. I will see you next time. Bye bye. If you have a question, you can stay behind. I'll stay behind to answer any question you might have. If not, then bye bye. Have fun. Thank you. Thank you very much. Stay safe. Bye bye. Bye bye. Thank you. Yeah, any question? If you have any question, then just let me know. We can unmute and talk. If not, then you can just leave. I mean, I'll stay here until 1 more minute. If no, I end the section. Okay, I hope you guys are all safe. Bye bye.